Hey, good morning, everybody. Hope you had a good weekend. Hopefully, you were good to your mother on Mother's Day. Hey, this is it. Last week, we're gonna finish up with the final on Friday, and then we are done. Just a little bit here to go over tentative weekly schedule. Monday and Tuesday, we're going to do exam review notes. Okay, some of these will be actual problems from the review. Some of them will be different. You are responsible for any type of problem on the review and any type of problem we go over on these notes. Okay, not going to go outside the scope of those. So I got to make sure that we cover everything that's going to be on there. Wednesday, no video or assignment. Thursday, no video or assignment. For that, and then Friday 7:30 to 9:30, all graphing calculator. What I am going to ask you is, if you can, to print it off and to do it on the paper. It is much easier for me to grade when you do that. Obviously, if you don't have printing capabilities, that is absolutely fine. Just make sure it's neat and a little bit spread out. Some of you are getting a little bit too tight. But put it on the actual review sheet if you can, or the actual test sheet. So today we got, and then we're going to have Canvas conferences. What I would do is go over those, and then I'm going to post the answers on Wednesday at 6 o'clock. Okay, so that's when your review is due. So right here again, let me just hit this again. Friday, May 15th. You may write any identities and formulas on the front and back of a 3x5 index card. Obviously, that would be the same as two fronts. No example problems. Upload Thursday night. I'm going to show you where to do that. Remember, this is 25% of your final grade. The exam review will be 10% of the exam. So if the exam's 100 points, it's 10 points. If it's 120, it'll be 12 points. Okay, it's due Wednesday by 6. Got it? And if it's late, then I'll have to take off points, which will result in points off your exam. All right, just a couple things here. Your grades, your Stark State grade. Let me go to the Canvas. All right, here is the home page. I put the weekly schedule up, so this should be on here as well. If I'm going to go to modules, okay, if you're in, this is something you need to be able to figure out. Okay, what grade do I need on the final to get either an A, to get a B, to maintain what I have? Okay, and I'm going to show you that. Under Stark State grades, I got your first period, sixth period, and seventh period grades listed by your ID number. Okay, so if I hit sixth period grades, and then it'll come to an Excel sheet, you would open that up. And then look, find your student ID. This is for all of second semester. This is not just the fourth 9 weeks. This is all of second semester. So you want to identify and make sure they're right. These are your quizzes. These are your tests. Okay, and this is basically your homework average. And for the second 9 weeks, I dropped your lowest homeworks, and there are no more homeworks. So everything should be up to date. So now you should be able to access that. And then you have a blank spot for final exam. Well, right now, everybody's final average does not include their final exam. This would be your grade if you got a 0 on the final exam. So let me go to this case here. I just did a quick clip, took out the student ID. This person has a 68.15, 62.78. Like I said, if they got a 0, that's what they would end up with. Now, your final exam is 25% of your final grade. So if you would get 100, basically add 25, and that would be the grade. So 78, 88, so a 93.15. Okay, if a person would get 100 here, that would be add 25. That would be 87.78. All right, but if you want to see other scenarios, here's basically what you need to do. Take your average. That is 55. Test average is 55%. This is 10%. Your homework average is 10%. And then and this is 25%. So take the average, 82.31 times 0.55 plus 82.11 times 0.10, or just 0.1, plus 93 times 0.1 plus, and then whatever you want to calculate, times 0.25. And so let me see here. So 82 point, whoops. Let me see if I can move these a little bit. There we go. So 82 point, whoops, times 0.55 plus 82.11 times 0.1 plus 93 times 0.1. Okay, now that all gives us, what did I do wrong? I don't need that in there, I guess. Okay, that's where you get to 62.78, and that's your grade if you get a 0 on the final, which hopefully nobody does. But now you can just plug in whatever you want for your final. So let's just say, all right, I want to see what will happen if I get an 85%. Now that's going to go in as a percent of the 120 points, whatever your points is. I'll put that in as your percent. 85 times 0.25. And so you get an 84. So if this person got an 85 on the final, they get an 84 for the grade. Well, an 80 is the lowest B, so you can figure out, all right, what do I need to get a B? And can I get a 75? So I'm just going to go in here and change that to 75. And I get an 81. So I could get a 75 and still get a B. Could I get a 65? And let's see. And that'd be close. No, wouldn't make it. So you'd have to get something over. So you could just keep plugging in numbers and figure out what values you would have to get in order to do that. You might even be able to do that on that sheet, but what you do is you change it for everybody else, and they'll be able to see that. So do not mess with that sheet. Just do it on here. All right. We're going to go through a couple things here. And now I'm going to pause it for 1 second, and I'll be right back. All right. As you look at the review, or if you have that in front of you, I'm just, like I said, going to go some different things. Make sure you reduce fraction. I do not have guided notes for these. Okay, you write down what you need. Keep these kind of with your other reviews so you know exactly what's going to be on there. These can be degrees or radians. Radians are harder than degrees, so I would rather go over that than the ones in degrees. So this goes back to your unit circle. What's a sine of 5 pi over 4, secant of 5 pi over 3, tangent of 2 pi over 3, cosecant of pi, etc. All right, if you need to draw the triangle or however you need to figure that out. So sine, it is the y value of 5 pi over 4. Well, what is 5 pi over 4? That is going to be 225 degrees. So that means it's going to be in the quadrant 3. Your reference angle is 45, and that's going to be square root of 2 over 2. But since it's in quadrant 3, it's got to be negative. So negative square root of 2 over 2. Secant. Well, what's secant? It is going to be the flip of cosine. Cosine is the x, so this is 1 over x. Well, what is 5 pi over 3? Remember, pi over 3 is 60 degrees. Okay, pi over 3 is 60 degrees. So this is going to be 5 times 60, which is 300. It's going to be quadrant 4. It's going to give me a reference angle of 60. That means the opposite is square root of 3 over 2. Adjacent's 1/2. Well, this is 1 over x, which is 1 over a half, which equals 2. So that means secant of 5 pi over 3 is going to be 2. Tangent of 2 pi over 3. Remember, tangent is y over x. Well, what's 2 pi over 3? Again, pi over 3 is 60 degrees. 2 pi over 3 would be 120. Give me a reference angle of 60. Square root of 3 over 2, 1/2. That would be a negative. So tangent is going to be a negative in quadrant 2. So it's going to be square root of 3 over 2 times 2 over 1, square root of 3. But we said it was negative. So you get negative square root of 3. And what about cosecant? Cosecant is the flip of the reciprocal of sine. Sine is 1 over y, or excuse me, sine is y, so cosecant would be 1 over y. Well, pi is 180 degrees. What's the coordinate there on the unit circle? It is negative 1, 0. Well, 1 over 0 would be undefined. Okay, so just find the exact values. This is important. This is something we've done a lot of. Make sure we know how to do that. Hey, in this one here, I'm only asking for the amplitude, period, and phase shift. I'm not going to have you graph this for this problem. Just find these. Well, amplitude, remember, take the absolute value of that constant in front. That is 7. So that's the highest and the lowest it goes. Period. Now remember, this has to be factored out already, that constant. So if it's in the form of, 2x minus pi over 4, you have to factor the 2 out, okay, and then make it pi, because that's going to change your phase shift. But this one's already factored out, and the period is 2 pi over b, b being the 1/6. So this is 2 pi divided by 1/6, which is going to be 12 pi. So that's our period. And phase shift is which way it moves, left or right to begin with. Okay, minus pi over 12. So actually, remember, it's the opposite. It's actually going to go right pi over 12, or you can just put plus pi over 12 for doing to the right, going to the right, or a negative for moving to the left. All right, so that's your amplitude, period, phase shift. Okay, this one here. This was probably one of the tougher ones in the test from this chapter. Find all solutions. Okay, all solutions, not just from 0 to 2 pi. This is the one where we have to do the plus, and we're going to find this in radians. Okay, so this is where you have to do the plus 2 pi n. I'm only going to give you cosine or sine. I'm not going to give you tangent. Okay, and this is also one where we would let, and if it's anything other than just an x, I'm going to let theta equal 2x plus pi over 6. So here's what we got. 2 cosine of theta equals negative 1. Cosine of theta equals negative 1/2. All right, where does that happen? Cosine of theta is negative in quadrant 2 and 3. That means that is negative 1/2. That would be square root of 3 over 2. What would the reference angle there be? It would be 60 degrees. Okay, and so that means that this is 120, and then this is 180 plus 60, which is 240, which will convert to radians. So this is what we do. So theta equals 120 degrees, which is 2 pi over 3 plus 2 pi n. Now for cosine and sine, you get two separate sets of answers. And so theta equals the 240, which is 4 pi over 3 plus 2 pi n, because that's the period of sine and cosine is 2 pi. All right, so take your theta out. And we got to put in 2x plus pi over 6 back in. And so I get 2x plus pi over 6 equals 4 pi over 3 plus 2 pi n. Subtract pi over 6. All right, so you get 2 pi over 3. I'm just going to mess around here and then erase it. Minus pi over 6. So you get a common denominator. Make that 3 times 2 is 6. So this is 4 pi over 6 minus pi over 6, which is 4 minus 1 is 3 pi over 6, which reduces to pi over 2. So I get 2x equals pi over 2 plus 2 pi n. And don't forget to divide by 2. And when you divide by 2, divide everything by 2. So I get x equals, now that becomes pi over 2 times a half, which is pi over 4, plus, that should be 2 pi n divided by 2, which becomes plus pi n. So that's one answer. All right, I'm going to get rid of that. Same thing over here, minus pi over 6, minus pi over 6. And then that gives me 2x equals, what's 4 pi over 3 minus pi over 6, which would be 8 pi over 6 minus pi over 6, which is 7 pi over 6, plus 2 pi n. Divide everything by 2, and I get x equals 7 pi over 12 plus pi n. Okay. Now you basically got two sets of answers. So x equals pi over 4 plus pi n, and then 7 pi over 12 plus pi n. And we have to put this in here for any, n can't be any number, it has to be an integer. For any integer n. So that would be our final answer there. Okay. Now, let's take a look at an identity. Our old favorites. Let's prove the following identity. Sine of x over 1 plus cosine of x plus sine of x over 1 minus cosine of x. Oh, excuse me, I'm yawning. Equals 2 cosecant. Well, what's the flip of cosecant? That wouldn't be hard to do right now. That's 2 over sine of x. So that's kind of where we want to head. A lot of different things you can do, and what we do in here won't be the exact one you're going to see on the test, but it just kind of give you a reference to look at. On here, we want to add these together. In order to add them together, you got to get a common denominator. That's what I would do first. So I got sine of x over, you got 1 plus cosine of x. And I'm just going to give myself a little bit of room. Well, for this to work, I have to get, this one needs a 1 minus cosine of x. That means the top needs a 1 minus cosine of x. And this one needs a 1 plus cosine of x. So that needs a 1 plus cosine of x. And sometimes we distribute, sometimes we wait. I think in this instance, in the numerator, we are going to distribute. And so I get sine of x minus sine of x cosine of x. Okay, I got a plus here. Distribute sine of x and then plus sine of x times cosine of x. Well, this gives me 1 plus cosine of x times 1 minus cosine of x. Well, this is what I'm shooting for. I don't have to see any cosines over there. So what I'm going to do is, first of all, combine like terms up here. And I have minus sine of x cosine of x. And I got plus sine of x cosine of x, which adds up to 0. And I got sine of x plus sine of x, which is 2 sine of x. And I'm going to go ahead and FOIL these in the denominator. And when I FOIL them, 1 minus cosine of x plus cosine of x minus cosine squared. Well, some of you already know that Probably could have just jumped to this step and put 2 sine of x over 1 minus cosine squared. All right, we got, all right, we're getting closer. I got this 2. I do see a sine of x, but it's in the numerator. But we remember 1 minus cosine of squared x equals sine squared x. And so I can replace that with sine squared of x. And then they cancel. And I left with 1 or 2 over sine of x, which is what I have over here. So it does work. Now remember, there's a lot of different ways to verify identities. You just have to make sure you follow mathematical rules in terms of common denominators, knowing your identities, going through there, and just be careful, because if you make a math mistake, you distribute wrong, you put down the wrong number, then you're going to be stuck. And I would always recommend just starting over. If it's just something's not working out, that's always an option. Okay, car wheel has a 14-inch radius. Through what angle to the nearest tenth of a degree does the wheel turn when the car rolls forward 4 feet? All right, well, it goes forward 4 feet. It has a 14-inch radius. You have to make sure your dimensions match up. This is in inches. This cannot be in feet, or this cannot be in inches. You got to convert. So 4 feet is 48 inches. Well, as it rolls, it's traveling along the circumference. So basically, that distance is an arc length. So that'll be 48 inches right there, that arc length. And we want to know the angle it rotates through. That would be this angle here. Now we got 2 things. We got theta equals S over R, which translates to S equals R theta. Either one of these will work. Well, we're looking for the angle. So I'm going to use theta equals S over R. And so theta equals 48 divided by 14, which is okay, 3.4285. But if you put down 3.4, that is radians. So this is radians. We want to the nearest tenth of degrees. So you have to convert from radians to degrees. And in order to do that, that means you need to multiply. You need to multiply by 180 over pi. So you can, I'm not going to use that. I'm just going to take 48 divided by 14 times 180 divided by pi. And I get 196.4 degrees. So that would be our answer. So I wasn't quite close enough there because I don't know. I'm not too bad. Probably actually went a little bit too far, because I think that would be 180 to there and then a little bit past that. So kind of in the vicinity. So theta equals 196.4 degrees. That is the angle it rotated. Okay, a point on the wheel of a rim with a radius of 50 centimeters has an angular speed of 0.8 radian per second. Okay, so that means in 1 second, it travels 0.8 radians. That would be this angle. What is the linear speed? Here's 50 centimeters. The linear speed would be the arc length traveled in 1 second. Okay, the arc length traveled in 1 second. Well, we know theta equals S over R, so that means S equals R times theta. So I need to know that arc length. Well, that's going to be, and this if it's in radians, we're good, which is 50, it's my radius, times the angle, which we know is 0.8. So 50 times 0.8 gives me 40. So that would be the arc length it traveled. Well, we want the speed. That's the angular speed is per second. That's how far it traveled in 1 second. So that's going to be our velocity at the same time. So our velocity is 40 centimeters per second. Now this one didn't work out too bad, but we also talked about there's another formula. Velocity equals r times omega. Now this is one that can be very useful, but a lot of times you can solve it more what I call the brute force method. You got to do a few more calculations, but you can get there. But omega is the angular speed, not the number of revolutions, not anything like that, but it's the angular speed, which we know. So this problem shapes up into the same thing because 50 is my radius, my angular speed is 0.8. I just know that that's my velocity. Here, I had to just make sure that I understood that's my arc length, and then since it was for 1 second, I could convert that to velocity. But that's probably a formula you want to throw on that index card for that. Like I said, I'm not going to go through every type of problem you're going to need. If you can't do a problem, you're going to need to come to a Canvas conference. Type it in or tell me. We can do it together. Okay, do not, and then don't, and this is due Wednesday night, so we also have the Canvas conference on Thursday to go over for any that you don't know how to do. All right, you guys, I believe this is the last page. Yep. Okay, you're just working on the exam review till Wednesday, kind of day at a time. Uh, make sure you highlight the ones you're not sure of. You guys have a great day. We will talk to you later.